So, guys, in this problem number 37, I was going to say 37 in French, 37, f of x equal 1/3 over x minus 2. What you need to look at is seeing this as f of x equal g of x minus 2, with g of x being equal to 1/3 to the x. And that should tell you that you have a shift to a shift down of 2 units. Remember, when you're having f of x equal g of x plus or minus k, when it's plus, it's moving up. When it's down, when it's negative, when it's minus, you're moving down. And that is a shift up, down. But if you had f of x equal g of x plus or minus k, when it's a plus, you're moving to the left. When it's a minus, you're moving to the right. So what you need to do is just graph 1/3 to the x, and then have a shift of 2 units of every of the whole graph g of x. Problem number 41. So problem number 41. What are we dealing with? Solve the equation. So we have 2 to the 3 to the minus x equal 8. In order to solve the equation, you need to have the same base. A to the b equal a to the c. And so you will be able to write b equals c. You have 2. You cannot simplify as much as possible 2, because 2 will be only 2. So you can expect to try to find your 8 a multiple of 2. And 8 is 2 cubed. So we're having basically a 2 to the 3 minus x equal 2 cubed. Now we're having the same base, and so we can equal the exponent. So 3 minus x equal 3. So we end up to have, I am going to subtract 3, subtract 3, and add x and add x. By doing so, x is by himself now, it is positive, and 3 minus 3 equals 0. So the answer is going to be 0. The set of solution is going to be 0. All right, next problem. So guys, number 47, just to make sure, because I think I stopped to the video at number 47. All right, my apology, guys. I thought that I started to record when I started to create the problem number 47, and I did not. So that's why you had this little kind of confusing moment. But here we are. So problem number 47, we have 27 to the 4x equal 9 to the x plus 1. What I tried to explain in the second line is some of you might see the relation between the 27 and the 9 as 3 times 9 equal 27. And some of you might start to think, okay, 27 is 3 to the 9 to the 4x. And then you might think that the 4x right here is just for the 9, which in fact is not the case, because on 27, the exponent is for the whole 27. Therefore, in fact, what you're supposed to have is a parenthesis right here. So you need to change the gear and try to find another way to express the same base both sides. You can see that 9 is a multiple of 3, which end up to have 3 cubed to the left, and 9 will be 3 squared. Using your rule of exponent right there, you are finally able to have the same base, and so now you're able to equal the base, and you end up at the end by solving a linear equation very easily to find x equal 1/5. Problem number 48, we have 32 to the x equals 16 to the 1 minus x. And so, same idea, 32 is a multiple of 2, 2 to the 5th. 16 is 2 to the 4th. Using the rule of exponent, we end up to have now the same base, because we multiplied the exponent together. And so now we can equal the exponent, and so we are able to write that x equal 2/3. Finally, the last problem. All right, guys, so what do we have? We're having, on problem number 58, a regular equation, 3 to the 2 minus x equal 9. We end up to have the same base by completely factorizing 2 prime 9 into 3 square. And so now we can equal the exponent and end up to have x equals 0. We are dealing with an equation, so we have a very one specific value of x. When we are dealing with an inequality, we are going to apply the same rule regarding trying to have the same base, but this time we are going to end up to have 2 to the minus x greater than 2, which end up to have negative x greater than 0. And if I divide by negative 1 both sides, because I will have to divide by negative 1 to get rid of this negative 1 right here, when I divide, I flip my symbol. So this is why we don't have the same symbol between this line right here and this line right there. Therefore, the set of solution is going to be, draw your number line, plot your 0, x is less than 0, so you need to go to the left. You're going to the left not because this symbol tend to look like an arrow going to the left, but you're going to the left because x is less than 0. Then you have a parenthesis on 0 because you don't have equal in your symbol, and so your set of solution will be between negative infinity and 0. There is always a parenthesis for the negative infinity. Finally, for the C being 58, 3 to the minus x, 3 to the 2 minus x less than 9, when before it was greater, so 3 to the minus x, now we have 3 to the 2 minus x less than 9, so which is a 3 to the 2 minus x less than 3 square, so 2 to the minus 2 minus x, is less than 2, so I end up to have negative x less than 0, and so x will be flipping the symbol because we divided by negative 1 to get rid of the negative in front of your x, and x will be greater than 0. So I draw my number line, I plot my 0, because x is greater. I am going toward to the left, to the right, parentheses because there is no equal, and so we end up to have a set of solution corresponding to, oops, I need to change that. There we go. The set of solution is going to be 0 plus infinity. All right, guys. So I think I correct all the problem. And if you have any question, just let me know. Actually, you know what? I think I'm going to do one more problem. And I'm going to do the problem 61. And I'm going to do the problem regarding 1 over 2 to the negative x equal, greater or equal than 1 over 4 to the x plus 1. I'd like to remind you that basically what we need to do is change 1 over 2 to the 2 to negative 1 and 1 over 4, which is 1 over 2 square, onto the 2 to the negative 2. All related to the expression a to the negative n equal 1 over a to the n. And right there we have a 1. This is why we have 2 to the negative 1. So we end up to have a 2 to the negative 1 to the negative x greater or equal than 2 to the negative 2 to the x plus 1. By using my rule of exponent multiplying, in these cases, the different exponent, I end up to have 2 to the plus x greater or equal than 2 to the negative 2 times x plus 1. So therefore now I'm supposed to do is, I'm having the same base, I'm having base 2 and I'm having a base 2. So I'm going to have x greater or equal than negative 2 times x plus 1. So I continue to do what usually I'm supposed to do, to distribute negative 2 times x, negative 2x, negative 2 times plus 1, negative 2. I am going to add 2x both sides, in order to have for me all the x. Because I'm adding, I'm not flipping my symbol, and so now I'm getting a 3x greater than negative 2. I divide by 3. I am going to divide by 3 to have x by himself both sides. Because I divide by a positive number, I don't flip my symbol, and so I end up to have x greater than negative 2/3. I draw my number line, I put my negative, if my 0 was right here, negative 2/3 would be right there. X is greater or equal. Because x is greater or equal, first of all, I will have a bracket because of the equal, and greater, that means I need to go to the right. And the set of solution is supposed to be negative 2/3 with a bracket toward plus infinity. All right, guys, I think I've done pretty much covered not pretty much, I covered everything that you need to know. So I will do another video regarding section 6.3 if I'm correct.